well, however embarrassing this might be, I'm just recording my voice and I'm trying to deliver some kind of lecture on computer science. This is not really intended to be something professional, but rather an experiment. I'm doing this for the first time, and I'm doing it mainly for fun. So maybe you will also have fun listening to this and watching this. So my name is Klaus Volko, and I am a computer scientist by training. And what motivates me to recording this lecture is that I have actually been aspiring to a university career, a career in academia, and well, it turned out I ended up in the software industry. And this isn't the worst thing to be in, because software industry can be quite a lot of things, and in my case it's a company that is close to research and works together with university professors. So I'm actually quite in the social environment I desired. But the thing that is bothering me is I don't have interaction with students, I have nothing to teach. I sometimes do research, I publish scientific papers, but I'm not teaching. And well, now I just had the idea, well, thanks to some friends at Facebook, that I could record my voice and record some kind of video and, well, talk about things which I would like to teach others. So let me start with a sample lecture, and, well, I will probably upload it onto the internet, and feedback will tell whether it has been a good idea to do this and whether I should continue this or not. In any case, I must tell you that I have been playing around with computers since I entered elementary school, which is already almost 30 years ago, and I was first primarily interested in computer games, and I was mostly keen on designing my own games, and this is what made me start to learn to program. And I don't know if this is the same with you. I know there are also some people who, for some reason, well, some of course are mostly into money. Some think they will become rich if they study computer science and start programming computers. But there are also some people who simply like a challenge, the mathematics, or maybe the art if they are into computer graphics or music. In any case, what I would like to confer to you is mostly that it is a rewarding job if you have the talent for mathematics and especially for logical thinking. You can become a good programmer with just some, well, experience. You just have to keep working on programs until you get enough experience, so you will be a fast and efficient and high quality coder. So what I actually wanted to start with now is some kind of introduction to mathematical logic, because I think this is the basis of computer science. And I think if you are good at this, then you will become a good programmer, or at least you fulfill a requirement for becoming a good computer. And this is already one of the things I want to tell you about. In logics, there are two operations which are called implication and equivalence. So, if you say that A implies B and B implies A, then A and B are logically equivalent. That is, just to think of an example. Think A is the statement, it is raining. And B is the statement, I'm walking with my umbrella. So maybe this is not perfectly logical, but you can say, if it is raining, then I am walking with my umbrella. And you can say, if I am walking with my umbrella, then it is raining. Now, these are syntactically valid statement, well-formed statement. They make sense. No, well, they don't make sense, but they are well-formed English sentences. And that is what syntax is all about. But semantics is about the meaning. So if I say, if it is raining, I am walking with an umbrella. Is this semantically correct? It is not, because it can also be raining, but you're not walking with an umbrella. Because maybe it was sunny when you left the house, and so you didn't think of the possibility that it might rain. And so you didn't take an umbrella along with you. So this implication is false. But if you look at the reverse implication, if I'm carrying an umbrella, then it is raining. Well, maybe I didn't express it clearly. Let's say it's not like I'm carrying an umbrella, but I'm carrying an umbrella to protect me against rain, to carry the umbrella in this way. Then it is a logical implication, because you wouldn't do that if it weren't raining. So a logical implication means if the premise is true, then the conclusion is also true. But what is if the premise is false? So if you make a statement, but in reality this is not true. Well, in classical logic, an implication in this case is always true. So if you start with a false premise, then the implication is always true, no matter whether the conclusion is false or true. This is also called ex falsum quodlibet. This is in Latin. So the early logicians were Latin-speaking people, and so they said ex falso quodlibet. From the false, anything can follow. And this actually means that the only time an implication itself is false is if you say that from a true statement follows a false statement. This cannot be the case. From a true statement always follows a true conclusion. So the two statements I said with the raining and the umbrella, they can form an implication, but they are not logically equivalent. The implication is only in one direction. And this is something that is quite important, not only in computer science, but also in proof theory, because you must know one thing. You can sometimes prove a statement by showing that there is a true statement from which this statement logically follows. And on the other hand, let's assume we have a false statement and we want to investigate another statement. What can this tell us? Well, if the other statement implies this statement, which we know to be false, then the other statement must be false as well, because a true statement cannot imply a false statement. And if we bear this in our minds, we can explain a lot of things in proof theory and in reasoning. And in computer science there's also this sub-branch of automated reasoning, when the computer is supposed to make logical conclusions. And this is something which requires that the programmer himself understands formal logic, mathematical logic well. So this is something which you should study. And actually, I have written documents about this. I've published them on my personal website. So Klaus Volko, that's my name. Google for Klaus Volko and you will find my website. And you can read what I have written about mathematical logic and study it. And maybe I will make some more videos, and I will perhaps try to find ways also to visualize what I'm talking about. Now I have only talked, but there are many possibilities in the video. So maybe I will keep talking about mathematical logic and maybe about other subjects related to computer science. In any case, don't take this too seriously. This is an experiment. What I said about mathematical logic is serious. It's not nonsense what I talked about. But the idea to deliver this as a video lecture is an experiment. So I will now hit the stop button and, well, let's see what the result of this has been. Thank you for your attention. I hope you enjoyed it.